All right, in this podcast, we're going to talk about metallic bonding and how the structure of a metal affects the properties. Metals form a lattice of positive ions that are in a sea of electrons. So metal atoms have what we call low electronegativity. Electronegativity means how tightly it holds on to its valence electrons, its outside electrons. So metals don't really hold on to their valence electrons. So because they lose their valence electrons, they have a positive charge. So here's our metal, and then the valence electrons from that metal atom and metal atoms all around it are all just kind of floating around willy-nilly in what we call a sea of electrons. Here's another depiction of it. When we talk about metallic bonding, usually I would just tell you, it's lithium metal. And I just write the one, the one little atom, right? Okay, well, that's not in reality what's going on. You don't just have one little metal atom that makes up a whole metal. You have a whole bunch of metal atoms that are all together in this big sea of electrons, okay? So it's a bunch of metal atoms. Here are some examples of metals. Hopefully you know what metals are, but any kind of metal, and it can also be alloys, which are combinations of metals. All right, so let's talk about the properties of metals. So metals are good conductors of both heat and electricity. They are shiny and lustrous. They can be pounded into thin sheets, which is what we call malleable. They can be drawn into wires, which is what we call ductile. And again, this is all because they don't hold on to those valence electrons. All right, so why do metals conduct electricity? So electricity is basically the movement of electrons, okay? So if you have a metal, it's going to conduct electricity very well because it has all those free electrons that can move out of the way and allow the electricity electrons to run through it. All right, malleability is the ability to bend or hammer something into a sheet. And metals are malleable because, again, they have these delocalized electrons that don't belong to any specific atom. So when you bend the substance or squash the substance, the electrons, because they're delocalized, they can move around, which allows the substance to change shape, and it can be formed into a thin sheet because there's going to be no repulsion between all of those cations because those little mobile electrons get in there and prevent that. All right, what is ductility? Ductility is the ability of a substance to be stretched into a wire. Metals are malleable for very similar, ductile, for very similar reasons that they are malleable. It's because when you begin to stretch a metal and move those atoms around, again, it's able to change shape because the electrons are able to move around freely. So the electrons are decreasing the repulsion between all of those metal cations, whereas in an ionic crystal, when you try to shift it, you end up with like charges lined up, and so the whole structure just falls apart, right? So it's all about those mobile electrons. All right, so if you will recall, vapor pressure is the pressure exerted by a gas so if we put it in a beaker, we have some substance in a beaker, and then we put it in a bell jar and we evacuate all the molecules from the bell jar. Then our substance in the beaker will start to evaporate, and the gas molecules are bouncing around, exerting a pressure or a force on the walls of the container, and that's what we call the vapor pressure. Metals have very low vapor pressure because they are attracted to each other because of the structure of the substance. So because you have all of these positive cations And then you have all these little mobile electrons all in here. Okay, all my little mobile electrons. It's all very attracted to each other. And because of that attraction, it's not going to want to evaporate. It's not going to want to change into a gas.